Hello and welcome back. This is Code Dive, and now we have a duo of speakers, Piotr Pietroń and Filip Olszewski. Now, Piotr is a technical and agile coach with over 12 years of professional experience as a programmer, Scrum Master, and software architect. He's lucky enough to have seen Agile function in all its glory, and ever since he's been eager to experiment with new ideas that could improve software development work. Privately, he likes to waste time on lost causes, such as trying to solve the unsolved Eternity 2 puzzle or trying to learn to play the guitar. Filip is a Java software engineer and Scrum Master here at Nokia. He's excited about software development and architecture, agile methodologies, and, wait for it, Neapolitan pizza. He explores new solutions for accessible IT education and mentoring, and recently he started blogging at his own blog, filipolszew.blog. Gentlemen, over to you.
Thank you. So, hello everyone. Today we have a pleasure to share with you our experience from implementation of feature toggling platform. And the first question that we want to ask is, why feature toggling? What is so important or interesting in this concept? So first, we need to understand the current situation. Yes, everyone is evolving towards the continuous delivery, which means that we need to deliver more software in small batches and very often. And why is it so that we are not doing this already? Well, let's look at our continuous delivery pipeline. So it consists, when we finish a feature, then we push it to the pipeline, and if we are lucky, it will end up in the production for the customer. But not always it happens like that. Sometimes we fail the production and we blow up the product. Especially when we work in a bigger team, the chance that we will break something will be much bigger. So what can we do then if this happens? Well, at this point we need to, for example, roll back all the features that we have provided and try to repair the situation. So to make it somehow less risky, we can introduce the verification environment so that the customer can check this solution before something bad will happen. Of course, this creates another step in the process that makes the delivery much longer. And at the end, we don't know that those tests actually work in the production. So not very good solution, and we need to try to push it even back to push it back to the test phase or design phase. Okay, so this is not only the situation that we are facing. Other cases when we are trying to push the feature to the production and we have not finished until the release date. So we have a couple options here. Or we can try to prolong the release and push the deadline forward, or we can try to fix it quickly and or we can try to hide it from the source code and push it without that. But then we are risking that something will go wrong and we will not hide it entirely and break the production. Okay, what else? If we are successful enough, then our product will be used by multiple customers, and which means that we will have multiple versions of our software. And every of this version will have its own set of features, though they will be different. We'll have to manage that. And it's not possible to do without introducing more pipelines, more branches, and more versions of our products, physical versions, yes, as a source code. So then, if we will break something, we'll have to fix all the issues in the multiple products, in the multiple pipelines. Doesn't sound very good. In time, it's getting worse and worse as we grow, as we are getting more complex. Also, this process is becoming more complex and harder to manage. It's getting slow, and the result is not predictable. So what can we do about this? Well, and here comes the feature toggling concept. Let's try to apply this feature toggling to this diagram. First of all, if we have the feature toggles, we can disable failed feature at the production, not affecting other features that were released at the same time. Then we can remove the verification environment, because now we can enable a given feature for isolated amount of people at the production site to test this feature before it will go live. So let's remove it entirely. It's much better. And then what about the incompleted features? So the same mechanism can be used to simply disable features that are not finished, but which means we don't require more pipelines and more copies of our software. Everything is in the same place, which means it's much easier to manage those versions. Now the versions are not physical copies with information about features hidden inside inside different pipelines. Now we have everything in one source code, and we can decide using some kind of a metadata what we will release, what given product will be at the end. And of course, now we just fix bugs once, because they will always happen. So I think it's quite an interesting idea, and maybe it's worth a while to invest and see what those feature toggles are.
Okay, thanks, Piotr. I think if we understand now the potential gain that we have from feature toggling adoption, we can introduce some basic concepts, so we can dive deeper later on and talk about more of those technical challenges that come when we try to introduce feature toggling in our system. So what is the feature toggle? Basically, it corresponds to a feature in our system, and it holds its state, which is usually just binary state, enabled or disabled. As you can see on this simple diagram, if feature is enabled, we run this part of code, and if it's disabled, we act like this feature is not really existent in our system. So this can be shown as a code snippet as well. Here the feature toggle is the use new feature variable, and we check its state, and if it's true, we run the method that executes given feature. And second variant of this is equally viable. You can imagine that we have an old implementation of some algorithm, and we introduce a new implementation, perhaps to increase the performance of the solution. So we use feature toggles to switch between the older and the newer implementation, and for example measure the execution time. And one thing to notice here is that this feature toggle is compile time toggle. So if we want to change the state, we have to comment or uncomment the line and recompile the code. And depending on our use cases, this might not be enough, and usually isn't. So later on, we will try to think what to do to make it this runtime, add this runtime aspect to toggling. And there are many ways how to implement toggle point. There are some two good practices to follow, and a natural progression into extracting the abstraction for toggle check. So you should encapsulate this toggle point from the usual business logic in your code base. So at least a separate method, maybe a class, something like that. And you should make the code, the actual code, or let's say code before toggling, be unaware of any toggling happening in a system. That's just clean. That will make this code still as testable as it was. So now about providing that unified abstraction, let's see it on an example. We start, as I shown you before, with a simple Boolean variable, and we check its state to decide what we'll do, which feature will be executed. And we want to add this runtime aspect to our toggling, so we need to parameterize it. And for example, we take the state from the variable and save it to a file. Now we need, for example, a method that will read this file and return the state for us. And now imagine that we have tens or hundreds of such pieces of code in our code base. It's just a natural, simple thing to do, that we should introduce some kind of abstraction that handles it at this one center point in our system, and it's called feature router. And feature router for now seems like a small class, but actually it can become a module, independent service, or the whole platform pretty much. And now that the router grows bigger, it can make the decision about whether feature is disabled or enabled, not only using feature state, but it can also use environment type. So depending on which, whether we are on test environment or production environment, we can decide different. We can create user cohorts. So we can, for example, set things up. So one of the features is a premium feature available only for 5% of the users. And this goes on. We can customize it as we wish, according to our needs. We can even define toggle hierarchy, where we model parent-child relationship. If you need it, you're free to do that. And last missing piece in the puzzle is that configuration I briefly mentioned, the place where we extract the toggles. It's usually a file, maybe a database, but we start with simple mapping. As you can see on the left, we have the toggle name and its state. And on the right side, we can see that it can evolve depending on whether you want to manage your toggles, for example. You can then hold also a business readable description, an expiration date, or perhaps an owner field, which might be the team that implements given feature. And putting that all together, we have the client code part, and client, not our client, but client to the router abstraction. This client code just introduces the toggling points. The router API abstraction, the module, it's responsible for evaluating the toggles and defining some custom rules as we wish. And there is a data source that holds the configuration I just mentioned. It can be a file on a file system or database on a central service. Again, this is really customizable. All right, so we have some basic concepts established, and we want to start talking about our story of introducing feature toggling in our project. And we had to face two initial decisions. So before we get to context and technical challenges, we want to tell you about what were the decisions and how we made those. And the first obvious decision we had to make is, should we use feature toggling at all? And this question is more than viable, especially because at least one company failed miserably, and they used feature toggling. I highly encourage you to check this out. We won't tell you the whole story. We have some more important stuff to tell you today. But long story short, they repurposed a 6-year-old toggle for a new feature, and when they toggled that on production, this old code turned out to be malicious or some test code. It basically sent thousands of requests to stock market, and in 45 minutes they lost $460 million, and they had to shut down on the next day. Sounds pretty dangerous, right? Yeah, but they made a lot of other mistakes as well. It was not only about feature toggling, and so we assumed that we won't fail that bad. Yeah, and Piotr, what were the other decision points we had when discussing this question?
Yes, so this sounds very bad, yes. A single mistake can lead to massive fail in the production and actual lose of the business. So we cannot treat this lightly. And besides of that, if we will introduce the feature toggling, then we will accumulate many features in the same source code. So the complexity will grow, and we can do nothing about this. Besides of that, an entire software development process will be affected. So we can expect that there will be many technical challenges and organization challenges for us to overcome. But at the end, the reward for the success is so big that we cannot simply ignore that. So we decided that we should actually try our strength and try to do this and use it. But under one condition, we should minimize all those identified risks and learnings from the others to minimize the risks from the beginning. Yes?
Okay, so we're in, and now second decision, equally important, is whether to use our own solution or choose an external product, perhaps. And an advice to you, I think you should generally start by assuming that there is an existing solution that is applicable to your needs, especially if you have a younger, more flexible project, or if your project is based on cloud architecture using cloud solutions. There's plenty of those, and we have small open source libraries, and we have all-out platforms. We call them toggling as a service, pretty much, enterprise solutions. So there is a lot on the market. Even though there are a lot of solutions, we decided to build our own solution. There are a couple of reasons behind that. We needed a lot of control over the architecture, over the technological decisions. We had that strong requirement to not have any outside dependencies, influences. We didn't want to share any client or R&D data outside to the outside world. And there is one particular reason that was, for me, very interesting as a developer. It turned out to be a great learning opportunity. If you have a solution that requires multi-layer competence development, it might be wise to drive that competence from the bottom. And engineers spending their time building those solutions learn about many technical challenges. So it helps us not end as Knight Capital Group, for example. Okay, and now we are ready to talk about those deeper technical challenges. And Piotr will tell you a bit more about context of our project, because that is pretty important later on.
Yes, so we already saw the risks that we are facing with, but this is not everything. We have decided that this solution and our own solution will allow us to tailor this to our own needs. And what are our needs? In our situation, we are dealing with a mature application that was developed over 10 years or even more. So we have many versions of our product. We have millions lines of code. And some of the teams created simple forms of feature toggling solution. So now, when we are doing our solution, we need to focus on integration problems so that everyone can use it seamlessly. Then the work is, as this product is very big, then the work needs to be distributed. We have multiple teams need to work on this simultaneously and share the same environment, because everything is integrated at the end. So those are the things that we also need to take into account, allowing them to work seamlessly. Besides of that, our application is not simple, it's a big application. So it's a distributed application with multiple instances and applications. And we need to somehow synchronize this and the execution of all those components. And we need to think about how to do this with our feature token platform. And at the end, we don't have the luxury to enter the production, which is very often the scenario that is described in other continuous delivery and feature toggling implementations. Our customers have very secure environments that we have limited access to. So our main focus will be to support the development before we ship it to the customer, and of course then other teams at the customer side can also take advantage on that. So lots of technical challenges, don't seem too easy, but I think we'll manage. Yes, Filip?
Yes, yeah, so let's get right back to the code. We'll start with a challenge that will be most relevant to the programmers who will have to write those toggling points in the system. And I guess a lot of people start when seeing those feature toggle implementations of those if conditions are worried, what about the tight coupling, what about increasing technical depth? And I briefly mentioned some good practices about writing toggle points, but let's get a bit more specific here. So we still have some business logic coupling and business and toggling logic coupling, and the example on the left is usually something that we see in classes that are still related somehow to business logic. And if we follow some basic design patterns or like good design principles, we usually tend to create codes in such form on the right. So we inject the toggled implementation already to our function, our class. And the toggling is happening somewhere else, somewhere before, for example, in a factory class. And there is one additional challenge here. And let's look at it with this example. We inject the correct implementation of an interface that we call logic here. And then we proceed to make some continuous processing in this example in an infinite loop. And we process some data. You might notice that we lost the runtime aspect of toggling now, because if something changes in the configuration, we won't notice it during this processing. So all in all, having all that in mind, our router API should deal with those two challenges to encourage that better design based on some design patterns and dependency injection at the client's code side, but also ensure that client won't lose that runtime aspect of toggling. And there are many ways to handle that. There's no one solution to this challenge. We want to show you one we've used because we stick to pure Java language without using any external libraries and dependency injection containers. Okay, this is the biggest chunk of code you will see at our presentation, so we try to highlight the parts that are most relevant at the moment. The first part is the setup phase. Nothing really interesting here, but just to show you that we've built some basic abstraction. We have the feature class now, and we have that factory that we'll use later on. We pass our basic feature router object and the feature we want to use. And now we have two components, two implementations. In this case, this is some kind of processing of JSON files, and one of the implementation, the new one, consists of some new feature called autocomplete. And what we do now is we use the factory to create a toggled component, as we call it. We pass the type we want to achieve, and we pass those components. And what we receive is the toggled component that has a proxy underneath. So if you look at the usage, on each call of the process method, the toggled component uses proxy underneath to decide whether to use the old implementation or the new implementation, right? So that basically solves the challenge. And as I said, it's not the only solution, but it's the one that worked for us nicely, and we didn't make any couplings to other technologies. Okay, and we arrived to the second challenge. This one is pretty concerning at the beginning, because as we have, as Piotr mentioned, we have some distributed applications. Many of those will use the single component, and we were afraid that we introduce a new single point of failure in our system. And there are two aspects of this challenge. The first one is to give the client's code this freedom of how to handle anything going bad at the router side. And we introduced error modes that can control how router behaves. Basically, using the safe mode, all the exceptions are locked and a default disabled state is returned. This can be useful in critical production environments when we cannot let any exceptions to happen and shown to our client, for example. And the second strategy is the fail-fast strategy, good for development, for first exploration, where we just throw the exception and let the client handle that. And okay, perhaps the more interesting aspect of this challenge is what to do when data source that holds the configuration is not accessible, for example. We started to think about how to solve that, and we actually identified some business use cases. So it's not only about failure here, but we actually want to achieve some additional results. by using our data sources. For example, we want different setups of data sources on different environments, or we want a configuration that is just set in stone, it's always there, so we are safe that even in the worst case scenario, we still have that default configuration. So we achieve that using resilient configurations and that backup abstraction. This is, on the simple diagram, we can see that if the data source is unavailable or it lost part of the toggle data, we can fall back to the backup data source, so we are safe, and we can configure many of those backups. Looking at the code now, we see an example of how to prepare our router using those backup abstraction. We point to a central service, which is our primary data source, and we then proceed to add backups. First is just some file. We point to a file on the file system that we hope it will be there as well. And if anything goes bad, we also add this backup of just default mappings of feature names and states, so we are safe in the worst case scenario. Okay, 2 challenges solved. What's next in the bug?
Yes, so we now have developers that can easily decouple their work from the toggling problem. And besides of that, there are some other interesting features that actually can help developers in work. Then we actually guarantee that the application will not fail because of our implementation. So now it's time to put this into practice, put this into environment, to be used by our applications and by multiple instances of those applications. It seems that it works. Yes, every part of the solution is working. But now the developer finished its work, and he wants to check, or she wants to check that the feature that he was working on is completed. The same is with the tester, who would like to check this feature before it's approved and toggled on, and the product manager, product owner. So we need to have some way to synchronize the state of the toggles and change them at the runtime. So as Filip mentioned, we already thought about this in the toggle component that will act as a proxy that provides the fresh information about the toggles. Now we need to centralize the toggle change functionality into some central place, like central toggling service. So when we will do that, we are now facing another multiple challenges. We need to somehow to deliver those toggles to our agents that are residing in the applications. So for now in our solution, we just try to pull it and cache the results. So eventually applications will have the current state, but at the end we would like to have this push mechanism that everyone will be informed. So this is one part of this problem, and then we have the other problem. We need to somehow deliver the toggles to our application so that everyone can see this and use it. So here we are using the same router abstraction and the same backups abstraction to define the source from where we want to get this data. So we can easily use a file, we can use the database or some existing configuration management. Okay, so everything is working, and now it's time to test our application. So if we use this toggle component abstraction, then we created a unit of new functionality, and we can test it in isolation. Toggling is not required in this place. So let's move on and integrate this with a module. So at the module level, it is not so easy because the module can be configured now in a different ways, depending from the feature toggle flags that were set. So now we need to somehow inject the toggling states that we want to use for test to that module. So the first solution was to actually provide this possibility to inject those states, and as I remember, we have some interesting testing logic that can be used by tester to make it much easier. And at the end, we have this entire application. And there is no other way than to expose the API to change the feature toggle states for end-to-end tests, to check, for example, all the versions that we want to provide. Are they working? Are all those features are working together as we expected? So this is only the interface that we want to provide, but feature toggling actually creates much more challenges for testers. Yes, now the testers will not have a simple test, but their test will have to be also toggled, maybe, or they will have to define what toggles need to be used in the production. Also, when the features are depending from one another, and the toggles are depending from one another, it will also cause a challenge for the testers. So those things are here before us. We hope we will find a good solution for that. Okay. Now, everything is great. Our application that is mainly in Java is working. But what if we have different components, like in Python or JavaScript, which is also the true, or someone else want to use this solution? So after this isolation of central service, we now can simply communicate with the service over the REST, and we can provide thin clients to the customer side implemented in this specific technology that someone wants to use. So it's important for us not only to provide our solution, but to describe what challenges have we found, create such kind of a blueprint for other implementations, and allow them to connect with our service. So this is our idea for now, how to solve this problem. Okay. And at the end, now everyone is using our solution, want to integrate this library to their own source code. And in some cases it will be straightforward. In some cases it will require a design, because we need to isolate the features that maybe are somehow embedded inside the code, and it's not easy to actually toggle it. And in some cases there will be existing feature toggling implementation. So in these cases we provide open abstraction interfaces to solve this problem. That if you have your own way to provide the toggles, you can simply implement our simple abstraction called reader with a function is enabled, because at the end what is the most important is to provide the information, turn on or turn on, which is a very powerful abstraction, because now we can hide every decision that we have made before we have returned the state, which means if we have an implementation and we have our own specific needs, we can simply extend this interface and define our own rules when given a feature should be turned on. There is also another option. You can cover our API with your simple implementation, but then you will lose the access to our convenient APIs like toggling component, as it works with our component. Okay, so this should be at the end the developers should be able to fix it quite easily, we hope. So let's summarize the challenges that we have faced.
Right, so we've dealt with some challenges across many aspects of software development. We've been deep into the code. We work with testers. I think we can agree that there is always a new challenge when it comes to testing feature toggled systems. We successfully integrated our solution into this distributed multi-language system, and even though we've faced a lot of challenges, we've solved a lot of them, we still have a lot of them on the horizon. And this is, for me, it's really nice about feature toggling is that you can go as deep as you need. You can start with a lot of basics. You don't have to use a lot of those machinery and all those different implementations. But if your needs are more complex, you can add to this solution and build on that another abstractions, another cool mechanisms. And I want to talk about one particular from this unsolved list because it's particularly interesting. What we haven't talked about regarding the technical debt created is the aspect of all those toggles staying in our repository after we release a feature, right? For some scenarios, we probably need that toggle for a week or a month, and we could actually get rid of it. So one of the problem is how to create a toggle cleanup process. You might have remembered that I've shown you this expiration date idea, where you define the date until the toggle works and then switches off, so you have to handle that. But there's some people found another really nice idea, I believe, which is to repurpose those dead toggles into feature counters. So each time we check if feature is enabled, we can assume that it is used in our system. And that's how we can identify unused features, which is pretty agile, if you ask me. And this is just one example, a bit simplified, but what we want to share with you here is that there is a lot of those technicalities that can be done to really tweak that feature toggling solution to your needs. Okay, and we reserved some time for challenges that were not as technical, but for us are equally valuable.
Yes, so first step was to check if we can actually implement something, what technical challenges are behind of that. We've got the positive feedback, which is very good, because then that means we will get the funding, hopefully, for the next phase. Now, what will be most important for us is to introduce this to the organization. This step that is commonly overlooked. Yes, the common scenario is that there is some new methodology. Someone says, "Okay, from today we are using it," and in this case, it will not be as easy. Yes, because we want to minimize some of the risks. In case of major organizations like our, we have multiple roles, major processes, major product, and everything is optimized. So it's not easy to make a change to such a system. Yes. To proceed with that, we need to carefully plan our actions and introduce it step by step, by engaging everyone, and at the end we will have to rebuild many of the processes if we want this to actually work and to be useful for everyone without the risks that we have mentioned. And the first step to implement this was to bring it to the R&D teams in form of a kind of a challenge.
Yes, and I was one of the people who took part of this challenge, and as a developer I was really excited about a bit customized different form of a hackathon, of a usual hackathon. And I think there is a bit of insight here to be shared with you, and maybe you can apply some of those customizations at your organization. So as we mentioned before, feature toggling requires a lot of this technical analysis up front. It's not like a new hot library you can just tell your programmers to use, and it will magically start being used in your project. On a lot of layers, there has to be this competence development, this exploration, and we organized a hackathon that is a bit more calm. The duration was 5 working days instead of, for example, 1. And all the teams were free to continuously get support from the architects. So it was more of 5-day brainstorming with the architects, and I think it's just a great approach to building that competence from the bottom, and not just commanding those new changes from the top and expecting that everything will just fall into place. Yeah, so if you would like to introduce for example, feature toggling, and your usual hackathon structure might not be fully applicable here, maybe you could try our version.
Yes. Okay, as you can see, we have a very nice logo made in Paintbrush for this purpose. Yes, and of course the results were promising, so we decided to move forward and push it. So we didn't want this to die out, this phase, as the competence were gained, and we started to work to create a project to, with a goal to identify the minimal viable product, the critical parts of the product that we need to have to make another step forward. So we have defined that the most important will be the adapter part that will contain the router providing the API for developers and testers. And it need to be very easily integrated. It need to be, it need to have this property of easy integration to existing solution. Then, because of all those risks and problems that it might cause, we cannot just provide this raw interface that would check the state of the toggle. We had to implement a convenient API, which and part of that API is toggle components abstraction and some other methods to minimize the negative impacts that feature toggling might cause on to our product. And then, of course, the central service as the way to work on the toggled code. So this is our first approach. We have implemented this, and it looked like the first feedback is very positive. So what next? As we said, the process contains of multiple elements. So we now need to face another challenge to provide the proper knowledge to every role in our system, adjust the design, change the composition way we are making, change the software engineering way that we isolate the responsibilities. Yes, our code need to be more single responsibility oriented, and open closed principle need to be applied also, so that we can easily change them. And then we need to apply this on the coding level, so that it is actually used properly, applied to the test phase. We need to change our continuous integration pipe so that it can use those toggles and bring us the main benefit that we are expecting to have. And at the end, it will change the version management process. Okay, so summarizing.
Right, so I hope we made one thing clear throughout this talk. Feature toggling is not just a small piece of technology you can quickly integrate to your system. It's really powerful. It's customizable, it's flexible, it can be and it's pretty surprising, right? As we shown you some if conditions at the beginning, and it quickly turns out that there is a lot of possibilities on how to expand this solution to something big. I highly encourage you, as I said, to read about Knight Capital Group story, because with great power comes great responsibility, and this is just a consequence of feature toggling being multi-layer subject. It's not happening only in the code, it's not happening in the tests, it's also about our organization, our mindset. So you should identify those risks, be sure about what you really need, and try to tackle all those challenges, exploring all the possibilities, and not just being conscious enough. Just try to be sure before you use toggles, before you, for example, decide that you will create your own solution, right? Try to ask those questions and make sure to not fall into a same trap that some companies did.
Yeah, so, and the next key takeaway from this lecture is that as you saw, there are many challenges and they can be effectively controlled. Even if it looks like it cannot be done, in most cases we can do this. Yes, and And don't forget that this is not just another library. It can cause several severe damage to our business if not used properly. We need to apply it to all the levels of our software development process, to all the roles, that they understand what is at stake.
Yeah, and that's all. We haven't explored the whole spectrum of feature toggling, but that's the basics and some of our story here to hopefully make you excited about it and read further about feature toggling. And that's all from us.
Thank you.
Thank you for your attention.
And try it.
Yeah.
I hope it will work for you also.
Thank you so much, gentlemen. Thank you very much. Piotr Pietroń, Filip Olszewski, thank you so much for your in-depth analyses. This is Code Dive. We're broadcasting from Nokia Garage here in Wrocław, Poland. Stay tuned for yet another presentation today.